Yeah, so I think we'll give the time to Cynthia to share us more info about the Odyssey sessions at the UN Science Summit. And then after that, the Data for Life team will be coming in to talk more about their solutioning around ETL, as well as their ongoing work on the imaging data models and even the strategist GUI. So over to Cynthia first to get us going. Thanks.
Yeah, thanks so much, Mukesh. So really excited to announce that 2 sessions on Odyssey have been accepted for presentation at the UN General Assembly Science Summit. And this is a summit that's been going on to help promote awareness of activities that would drive toward the sustainable goals for the United Nations. And so this is the first session, which is going to be on September 18th at 8:30 a.m. Eastern Time. And we've got 2 people from APAC. We've got Chan and Nicole. And we're going to have really trying to showcase the global reach of Odyssey. So George will kick off, and then Agnes from the co-lead of the Africa chapter will go, and then we'll have Chan talk about how rapidly work was able to be produced during the COVID pandemic. And Nicole will talk about the really exciting new information about establishing an Australian health data network. And then the second one will then highlight the work from Europe. So Peter and Katya will talk about Eden and the Darwin EU initiative. And what's important here is that it's actually being used by a regulatory agency to help them with their decision making. Julio will be talking then about what's going on in Latin America, and then I'll give a talk about opportunities to learn more about Odyssey at different levels, from short course, from the tutorials at the symposium, to short courses, to master's and PhD programs and postdoc opportunities. And then Patrick, our wonderful leader, will wind it up, and we'll have a Q&A session so that people can send in questions and can have a little bit more of an interactive program. So this is the program that I just ran through, and you should register so that you get the link to the Zoom meeting. It's important to register because I think the more registrations we get to this, then I think it signals to the organizers that Odyssey should be at the table for future science symposia. So I will give these slides to Mukesh to post, and please do go on and register. That's it. Thanks.
All right. Thanks, Cynthia. I think this is really wonderful to hear we're going global, getting this known. These are all online sessions, right?
Yes, that's correct.
Okay.
All online.
Okay. Yeah, I think that'll be great. We can tune in online. Any questions for Cynthia? All good? Yeah. If not, yeah, we'll move on to the Data for Life team. Over to Karthik and Peter. Yeah. Thanks.
For a change, the hosting of the slides will be somewhere else at the part where I speak. So because we have screen sharing and stuff, so it just makes sense that we stick to one machine. Okay, super. Yeah, good morning, everyone. For those of you who know me from before, I am Karthik. I work for Data for Life, and I have a few of my colleagues here, and we're going to talk about how we are working together with the Odyssey community. Yeah, mouthful of a title, but the idea is it's kind of divided into a few parts where we talk about who we are, sort of, and give you an idea of what we do. So in case you don't know us, then you have a bit more idea of what we are doing from before and what we have achieved in the past. And then I think Peter will talk about multimodal data handling, especially focusing around the imaging data, like Mukesh mentioned. And then we have Amit, who is our data scientist, and he will talk around how we are doing network study design with data to evidence, incorporating the newer Strategos ideas. Next slide, please. All right. Who are we? We are Data for Life. We are a not-for-profit based across a few geographies, with our main office being in Potsdam in Germany, and then another office being here in Singapore. We are essentially very mission driven, and our mission is that we want to digitalize health research so that it kind of breaks the silos around existing data sets, brings in new novel data sets through wearables, patient reported outcomes, etc. And essentially the idea is that we advance public health and personalized medicine. And our solution, data to evidence, is open source, and we will talk a little bit more about that later. But yeah, as I said, our solution is completely open source, and you can use it from the link that I will provide at the end of the presentation. Next slide, please. Just to give you a quick idea of the different kind of solutions we provide, we try to sort of address the health researchers' needs end to end. From data collection to data access, and also discovering data that might be very difficult to discover before, thereby fulfilling the FAIR initiative of things. So we have one solution called Collect, which is handled by one of my colleagues, Tim, here in Singapore, and it is a sensor data collection platform which essentially helps the researchers to set up a research study and collect data from sensors, wearables, and questionnaires. And yeah, in a very super intuitive, easy manner, so that it's not super complicated or clunky to set up these studies, and you can get moving faster. Data to evidence, which is the product I lead, it's a health data management solution. So essentially, it's an end-to-end solution for extracting data, harmonizing it into a common format, in this case OHDSI, and then storing it in a very secure manner with very strict access regulations, where you have fine granular user management, etc. And then eventually using it to analyze the data so that you can derive insights. And then we have another product called Data for Life FAIR, which is a metadata catalog. So if you're an institution which has hundreds of data sets and you don't know how to make it easier for researchers to find it, and researchers find it quite difficult to look through the metadata, then this is a great solution. It essentially helps the researchers discover data sets that might be suitable for secondary research. Next slide. So I will not be going into depth in Collect and FAIR, because the point of, or the product in focus here, is the data to evidence product. And essentially, as I have already mentioned, it provides end-to-end access to real-world data. So you can see that we can ingest multiple modalities of data, like electronic health records, lab records, genomics, and image metadata, which is what we will focus more later. And these can all be harmonized into a single data set, and then the same solution can be used for researchers to access the data set and run analysis on it. Next slide, please. And a quick note, the solution is right now we have this big project where we are powering an AI-enabled multimodal health data platform for discovery, where essentially around 11 million electronic health records are present in the OMOP CDM. And we have customized some OMOP extensions for genomics, pathology, imaging, and ECG. And as more data modalities are rolling in, we are continuing the work of customizing some OMOP extensions. I cannot go into super detail on this, unfortunately, but as you can see, this is the summary of the whole project that we are doing. And then essentially the idea is that you have real world data that the researchers can use to generate clinical insights. And you can see a bit more information about how we have done it. It's based on Kubernetes, so it's completely containerized. The siloed data sets is the whole idea, that we break siloed data sets, we connect them together, so you have multimodal data analysis possible. And we are also looking into cross-institutional network studies now. And essentially the idea is that your researcher has everything they need on one single platform and does not have to run from pillar to post to get access to things, or request access, discover things, and do their research. I think I will stop at this point with the general talk around Data for Life and the work we do. We are happy to reach out to us if you want to talk to us more. And again, I will give out a call out again later. I think I'll hand it over to Peter now to talk more about our multimodal capabilities, especially around the imaging data. Peter, all yours.
Yes. So, I mean, like Kartik mentioned, I mean, in these projects, I think we really come in touch with multiple data modalities, but I think there as well the integration is happening in phases. So some, so some are basically completely in the, in an OMOP standard and standardized. Some are more in an early stage where I think it's still relatively customer specific. So therefore, basically in the open source platform data to evidence, there basically imaging data is integrated. And then I think what we are currently quite actively working on is as well oncology data to as well enable their specific filtering, for example, for episodes and so on. And other data modalities are still in a more early stage and not yet basically part of the open source platform. So let me go into more detail regarding imaging data support. So what we did there is based on the work by the medical imaging working group. And so the idea is that in our platform, we more or less enable the more or less end-to-end pipeline. So you have the DICOM files, then we have ETL jobs to extract the metadata to bring the data then to the OMOP CDM, to the medical imaging CDM. So basically the extension which was developed by the working group with some modifications. I will talk about that later. We also have the possibility to actually load the actual image data. So we have some initial support for basically running a DICOM server as part of the platform and then storing the imaging data directly there. And then once all the data is integrated, then it is possible with our cohort building tool to basically create patient cohorts, identify basically which patients are have the relevant information for the research question, and then as well to retrieve the images for these patients. Yeah, so regarding the data models, so we took a look at basically what the medical imaging working group did. And in our case, we decided to as well support a variety of that. So we introduced basically one additional table, which is storing the DICOM metadata. The reason for that is that I think in the normal approach, the imaging metadata is as well directly ingested into the OMOP CDM, which has, I think, the advantage that you can basically filter it with Atlas, for example, but has, for our basically partners, it was not acceptable because the people who get access to the imaging data and the people who get access to the EHR data are not necessarily the same. So it's basically not one basically process, but it's two different processes. Mm-hmm. And so therefore for data access control, we basically separated out to, as well as they have quite a lot of data. If you basically, there's possibility to do it basically via row level security, but then it has quite a significant performance impact. I think another basically limitation is that I think the standard OMOP tables, I think they have relatively short fields. So therefore not always basically the whole basically DICOM metadata can be integrated into these, which basically in our approach is possible. But in our platform, we actually support both approaches. So basically if you create basically an OMOP CDM with a medical imaging extension, you get basically our additional tables and the medical imaging group extension. And then as well in the ETL process, we support basically both ways of integrating the data. Then basically the next step of basically supporting an additional data modality is actually getting the data into the platform. For that, we actually have quite a bit of tooling in our platform. So we have there basically tooling for the whole process. So basically starting from the vocabulary mapping, there we have the tool will basically do the mapping of the vocabularies. We have there support for finding similar concepts based on full text search and as well on semantic search. And then we have basically which probably for imaging is then we have basically support for designing the mapping. That's basically based on the existing OHDSI tools of White Rabbit and Rabbit in a Hat. And then we have actually a tool to really actually implement the actual pipeline, and I will demo that shortly. And then I think that the next step, once the data is integrated, you created the data model, you integrate the data, then the next step is that actually researchers use the data. And there we have our cohort building tool, where we added basically support as well for the imaging data. And as for that, I will be demoed in a minute. yeah, then I would now jump actually to the demo. Let me share another tab. Yeah, so what you can see here is basically the admin interface of our platform. So there we have basically user management, dataset management. So here under dataset management, you would basically can add a new dataset where you can basically decide on that you would like to add a dataset, which basically OMOP CDM plus a medical imaging CDM. And then basically here, you can basically design the ETL process. So this is basically, I mean, we here directly opened basically one of our data flows, in this case, the DICOM ETL flow, where you can see basically a visual interface which describes the flow. So here, I mean, let me just walk a little bit through this UI. So on the top here, you can create a new flow. If you create a new flow, I mean, you choose the name, and I think one of the key things is that we basically offer templates for multiple functionality. So you have, I mean, we have basically a template for NLP, so for extracting facts from free text. Then we have here these flows related to the imaging. So one for the vocabularies and one for the metadata. We have a flow to ingest mimic data, and then basically just to load OMOP vocabularies, and as well, I mean, to load synpath data, but that's basically, I mean, a template for loading basically data from CSV files. And then basically once you create the flow, you can add here basically nodes. I mean, so basically these boxes, and there we basically have support for multiple functionality. So you can write basically transformations in Python, you can write them in SQL, you can query a database for getting data, and then you can basically write the data to the database. And we as well basically are still, I think, in the process a bit to add basically things like the concept mapping, and then basically, functionalities for designing the mapping and then actually using it as well in the flow. Let me just walk, I mean, so this is basically a flow to load the metadata. The flow to load the vocabularies is a different one. I will not show that in detail today. I will just basically show as an example basically how the metadata get loaded. So basically we have one node which is just basically reading the DICOM files, then extracting the metadata. Then we have here basically a node which is then reading the vocabularies. Let me just jump into that. So that's basically, we are connecting that to the database, running a SQL query to get basically the relevant vocabularies. And in this case, basically, I mean, the DICOM specific source vocabularies. And then basically the metadata which got extracted and the vocabularies are here basically combined. Let me as well jump into this node. So here we basically have a SQL node, which is then basically reading from the previous node and basically doing a join statements to combine these two data sources. And then basically we go on and basically do further transformations. I will as well jump into this. So this is a Python node. So here we do some more complex transformation. We take basically the output of that SQL statement and do some additional transformations to bring it basically to the OMOP CDM standard. And then we have here on the right side basically the different nodes which are basically then really writing it to the database. Let me just, I mean, so here we are basically writing the EIV table, and then we write here basically the image occurrence table, some procedure occurrence and visit occurrence. And let me just take here one example. So basically there's one node which basically just selects which table should be written. And then the next node is basically just you select to which database table the data should be written. And that's basically how you can then graphically basically design such in data ingestion. And as well, basically, if you need modifications, you can basically take our templates and adjust them according to your needs. And then basically here is basically the button to execute it. So I think we have here a very small data set. So it actually goes quite fast. And so once it's executed, you will actually, so this was executed before, this is why you see it already. You can see basically the outputs of the node, and if an error occurs, there are basically an error would show up. And basically, if you click on output, you basically get some information, how many basically items were processed, what the schema is. And if there would be errors, you could basically see there's the errors and then adjust basically the transformation. And for basically a few more on a regular basis wants to run such a flow, and if you as well basically want to monitor basically how it was executed, then we have basically this jobs UI where you can actually see the last run, which I just finished here a minute ago. And there you can basically get an overview of the execution of that flow. And there you more or less you see here again the same nodes which you saw before, but you can see basically what was the execution time, and you can basically see the logs of the flow in case you are interested in specific details, and you can as well basically for each node jump into it and see the specifics logs of that node in our platform. And that's why basically this here in this jobs functionality you can as well define the basically schedules to execute such an ETL process on the regular interval. And so then basically you now created the data model, you ingested the data. So the next step is the researchers actually would like to use the data. So for that, I will now jump to basically from our admin portal to our researcher portal. So I think we showed that basically before, I think in April. So if you are interested in the details, I think there I think you can take a look at the recording. So I will quite quickly go through it now. On the landing page, you have basically the overview of the data set, and there I can see here that's basically our imaging data set. So let me just jump into that. And then I think I will just directly go here to basically cohorts. That's basically the tool we have to create patient cohorts. And let me just create a new one. So on the left side, that's basically our filtering panel, and on the right side is the visualization area. And here you can basically now create a cohort based on the imaging data and based on the OMOP data. So you can basically here interactively choose basically what you would like to see on the x-axis. I mean, for example, you can just basically see the gender distribution of the data set. I mean, here on the top right, yes, I see basically the number of patients. So it's a quite small data set. And now you can see that basically we have roughly 3,000 females and 1,200 male patients. And so you can interactively basically adjust the visualization. So you can choose here basically the demographic data. I mean, we filtered it here. You can actually show the whole OMOP data model. Currently, we basically, this demo is limited what you can see, but that's, I mean, yeah, the whole OMOP data model is available based on the configuration, and you can basically filter the OMOP entities and as well as the imaging entities. So let me, for example, add here basically the modality. So we have a quite small data set, which I mean, just some sample data set. And now you can basically see, I mean, you have the distribution between gender and then basically the modality. And you can actually now select basically one of these bars and add that as a filter by clicking here on the top button. And then you can basically see immediately the visualization updated, and on the left side, basically the corresponding filters of the selected entity are entered and applied. And that's how you can basically then build basically, I mean, identify the patients which are relevant for your research question. And as well, I mean, you have the flexibility of all the OMOP entities and as well basically all the imaging metadata. And then you can just basically save your cohort. I mean, I just give it a name. Which stores the cohort definition, and then afterwards you can basically run the analysis. And that's where I would now hand over to Amit, who will basically show how we basically run basically typical studies in our platform.
Okay. Thank you, Peter. Good morning, good afternoon, everybody. So my name is Amit, and I will be discussing the topic of OHDSI network studies and what are the features that we offer on data to evidence for network studies. So just a brief summary of if you look at the OHDSI ecosystem, then there are at high level 3 categories where you can create network studies. For example, the clinical characterization or patient level prediction, which is also called PLP, and similarly the population level estimation, or PLE for short form. So each of these studies actually tackle different kind of questions. The clinical characterization is more about statistical analysis, whereas the other two are more about model fitting and predicting the outcomes and so on. So I'm not going to go in detail for these studies, but because today's topic is more about data to evidence perspective. So let's discuss how these studies are being done traditionally and what are the current approaches. So if you look at the traditional approach, as a researcher, you can create an R package for your study. So this R package basically includes what cohorts you're using and the R code to execute those cohorts and other modules and so on a particular data set. And then once you have this R package, what you can do is you can actually distribute this package to all the data partners. And on the data partner side, basically, people who are willing to participate in the study, they can simply download your package, configure and install their system based on the dependencies that you mentioned in the package. And then after that is done, then they can run the study on their side and hopefully giving the results back to the final coordinator of the study. So that's the traditional approach. But then comes Strategos. So Strategos is another HDSI module, and it offers some modular platform, basically where you can use. You're still using HDSI module, but very easy to use wrappers on top of that. And what Strategos offers is you can create your study specification using the Strategos modules, and the output of that is a JSON document. So now instead of distributing the R packages, you can simply distribute these JSON documents, and anybody, any data partner who's willing to participate, again, can simply download these JSON documents and run very standard Strategos scripts that would consume this JSON document to execute the study. So this JSON document actually encapsulates lots of details, including what are your cohort definitions, what are the modules you're using, what are the settings for each modules, and so on. Yeah, so all this is encapsulated and packaged into this JSON document. Then once the study is executed, the results could be populated and uploaded into the database, and then later on shared with the other partners in the study. Right. So although Strategos simplifies and streamlines lots of issues, I mean, it does offer a modular platform, but what we have learned from our experience in the community is even at this date, some of the data partners are actually facing challenges even with setting up the Strategos system. And also technically this setup is still a little bit complicated, and depending on your particular situation, it could be a little bit complicated to set up as well. Right. So to this point, we would like to offer in data to evidence, we offer a different approach. So what we have is we are offering Jupyter notebook based interface for Strategos study design. So we have built these features on top of Strategos, but we are providing a Jupyter notebook based interface. So what is the advantage of that is basically as a researcher, you can focus completely on your study question, and you don't need to worry about configuring, installing these HDSI modules and R libraries and Java libraries and so on. Right, so you can just open up the notebook and start writing the code specific to your research question. On the back end, there is an execution engine, which is basically a Docker container, and this engine has all the dependencies that would be most commonly used, including the HDSI and Strategos modules and so on. If you want to use any custom or third-party modules, you can also install these modules in the kernel and the notebook as well. Right. A second feature we are offering is when you're writing these notebooks, you don't always have to write from scratch. You can actually use the pre-built templates. These templates basically offer the boilerplate code based on which template you choose. So these templates would actually give you the most commonly used modules and the default settings for these modules. So you don't have to write your code from scratch. Next thing is the decoupling of study design and execution. So what we offer here is a study viewer. So as a researcher, when you have created the study specification, and on the data partners side, when you execute this study, basically there is a study viewer, which I'm going to, all of it, by the way, I'm going to demonstrate in a minute. But so we offer a study viewer, and as a data partner, what you can do is open this study viewer, you can see a list of the ongoing studies at the moment, locally as well as in the OHDSI network. And depending on which study do you prefer to participate on, you can basically fetch that study and execute that study on the particular data set you have, and thereafter share the results with the community. And lastly, we have also integrated Shiny app-based result viewer for you to visualize the results of the study. Yeah, and I would like to highlight this feature is still under development. So we, at this moment, we have integrated the core functionality, but there will be many more visual changes in the coming future. All right, so then for today's demo, I want to specifically talk about one of the network study types, which is a characterization study. And we have taken the liberty of choosing one question. So we're looking at all the patients with prior diagnosis of depression, and we are interested in understanding, out of all the treatment options available there, what treatment options the particular patients were exposed to and in what order, and did patients change the treatments from one treatment to another at some point of time. So we will basically want to understand the pathways taken by different patients. Yeah, and obviously the benefit of these studies are well known, and so it gives you insights into what are the common treatment choices and doctor preferences and so on. All right. So with that, let's jump into the specific demo. I would switch to the D2E system. Let's go to the landing page basically, and let me change the data set to synthetic 5% data set. So I will be using this synthetic data set for demonstration. So all the results you see are for demonstration purpose, and they may not make any sense clinically because this is not a real data set. Yeah. Okay. So before jumping into the notebook, I just want to briefly mention something in the cohorts. So obviously, when you're creating a study, you would work with a set of cohorts. What we can do is actually add these cohorts definitions to the D2E system. So here you see a list of cohorts that are available right now. So I've added these 4 cohorts for depression and some exposures that we have. For these cohorts, if you want to use them, you just need to know this ID that's here. And by using this ID number, basically you can use them in the notebooks. So let's see how do we do that. Yeah. Let me switch over to the notebooks tab. So when you click on this button here, the notebook menu would pop up, and from there actually we would see like a bunch of notebooks available to us. Let's see. It takes a bit of time to load sometimes, so let's wait for it. Okay. All right, so it's loading now. You go to the notebook section. Okay, so this is the menu we have here. So by default, there is one notebook open, but you can change this notebook here. So on the left side, there's a button. These are the available notebooks now. You can select any one of them. Then you have options to export this notebook. Once you have a notebook, you can actually export this notebook and save it. And then if you have an existing notebook, you can also import that notebook here and start working on that. You can also create a new notebook. That's what we're going to do for the demo today. And here you see the option to connect to the kernel. So this kernel is basically another Docker container that's running in the backend. You can simply connect to that. The kernel has all the necessary modules loaded in, and you can connect and start executing yourself. Okay, so let me now create a new notebook. So we click on the new notebook button and give it a name. Let's call it a treatment utilization or treatment patterns pathways notebook. And then here you have a bunch of templates available. So as I said, like depending on your use case, you can choose the most common one. And let's say for this one, I choose the treatment utilization. This should include all the boilerplate code for you in the notebook already. Okay, so here you see like some of the code is already loaded. And so it's a simple notebook, and we are basically looking at this simple question of depression cohorts and the treatment patterns for that. Okay, so let's connect to the kernel. Now we are ready to execute the code. And there is And there's one more feature actually available. If you see on the right side, on the corner here, there is a chatbot box available. So if you click on this button, what will happen is we open a prompt. Basically, this is a chatbot which you can talk to if you want to discuss anything about your notebook. If you have any queries or if you want to understand more about the notebook, then you can discuss with this large language model. Yeah. So let's briefly put one query. Let's say briefly explain this notebook to me. Let's see. If you want to understand what is there in the notebook and what is this notebook about, and if you have any other queries, feel free to interact basically with this chatbot. So right now this is a chatbot, but in the future we want to make this an agent, which means you would be able to manipulate the notebook cells. You can add new cells or modify the existing cells based on the natural language interaction here. All right, so let me close this. If you click on this, then this pop-up will go away, and now we're good to go with the notebook. So let's go through the notebook. It's a very simple notebook, so let's go through that. We are already connected to the kernel, and we are good to execute the cell. So first thing is we start with importing the necessary libraries. So obviously Strategos is there, but there's one more library. This is RD2E. So this is the library that we built in-house, and this library helps you to couple of things. For example, if you want to import the cohort definitions, like here, if you want to read the cohort definitions, then you can use this library, pass it the cohort IDs, and then this would simply load the cohort definitions here. And this library is also used to execute the Strategos flow that you will see in a minute. So let's run these cells. So if I execute this cell, all these libraries are imported. And then now next, let's take these cohorts. So all the 4 cohorts are loaded. And then I've added some configuration about the dates I want to study, and I've added a cohort generator module in the study. Let's execute this one. Next is I'm adding a treatment pattern module. So this module I'm using to create the sunburst diagram that we're going to see later from the treatment pathways. So here we add this module with some default settings and so on. You can always obviously change these settings, but let's execute this cell. And then having set up this, you can basically create an empty analysis specification and add these modules to that specification. This is where that JSON document is created. So when you execute this cell, this creates a JSON document, which you can obviously inspect as well as share with the data partners. Yeah. So this JSON document is created. Now we're good to execute the study. In the last cell, basically you can name what is the name you want to give this study, and then some other configurations about whether you want to upload the results to database or not. And then last is we use again the RD2E library and run the Strategos flow. So if I execute this cell, what it does is in the background, it triggers another process that takes all these execution settings as well as the specification file that you created, the JSON document, and then it executes the Strategos study on the particular data set that we've selected here. So in this case, it's INPUF 5%. All right, so when this flow is executed and the results are uploaded to the database, what you can do is you can launch the viewer. So let me show you where you can do that. So here you have a studies tab in the admin portal. Okay, so let's refresh this page. Okay, so when you go to the admin portal, there is this studies tab. Here, when you click on this, you see all the studies that are executed locally. If you choose a data set, then all the options on these studies would be highlighted. So these are all the local studies, and we have one more option, the network studies. So here, if you click on the network studies, all the studies that are executing in the network and are pushed on a particular GitHub repository would be shown here. So as a data partner, you can also fetch one of these studies and execute that on the data set that you have. Since we created the study locally, so let's choose this data set, and this study is already executed. So we can open the viewer here just to visualize the results. So we have embedded a Shiny app-based result visualizer, and you can see this is a very familiar interface. So we had two basically modules. One was the cohort generator, and then another one was the treatment pattern. Both of these modules are here available on the left side. So if you click on the cohorts, then you see some stats about which cohorts were added and how many patients were there and so on. And then the next module is the treatment pattern. So when you click on that, you see the sunburst diagram that was created using these cohorts. So from this diagram, obviously you can analyze things like which is the most prominently used treatment pathway for the first line. So in this case is SSRI and so on. And then what is the second line and third line, and what are the other pathways that patients are opting for. Right. So this is where you can analyze this. Again, just to emphasize that this analysis was done on the synthetic data set, so there is no meaningful clinical conclusion here, but this is just to show the functionality that we have here. Yeah. All right. So and last thing is like this feature is still under development, and we are still working on the cosmetics of this UI. So in the future, you will see a few changes coming to that, but the core functionality is integrated already. Yeah. So that's all for the demo, and now I will hand back to Karthik. Thank you.
Thank you. I know there's like a bunch of questions probably waiting in the pipeline from a lot of people. I will get out of the way. Just close off the whole thing, just to give you an idea of where you can meet us, see us, and some idea of what we are doing with the OHDSI group. So for Atlas, we are working with the Atlas team right now on a new UI, which essentially aims to reduce the entry barrier for new users, which has been a common feedback that the learning curve is quite steep. It kind of scares off some new users who are also slightly non-technical. So we are trying to help into making it a bit more user-friendly. Yeah. So we have 3 work streams that we are currently actively working on. We have user interviews. So there was a call out that went in the Atlas work group, and we have conducted approximately 12 user interviews with more in the pipeline. If you have not received such kind of an invitation, I'm sure we can finagle one for you, and we would love to talk to you. And then from these user interviews and from our own experience of having developed products, we are doing a redesign of the user interface, and then we will help in the implementation of the new user interface. Just to be very clear, this is all planned for Atlas 4.0 at this point, but things could change, right? If you want to see the new prototype, this is going to be presented by us at the Global OHDSI Symposium as part of the Atlas work group. We have gotten a slot there, and we will show you the new interface and walk you through it, and we will listen to all sorts of feedback that will come from the crowd. So we'll be quite happy to do this. Next slide. Other than that, we also have a hands-on collaborative session where we are trying to design a network study using the interface that has been showed just now. And so you can play around with a data set and try to set up a network study and see how it works. Tell us whether our solution is very amazing or just slightly amazing. Every other response will not be recorded. We are very open to feedback. So please do join us. So the QR code here is actually again, similar to what Cynthia said, a registration QR code. So we also know how many people we could potentially expect. So this is not an OHDSI registration QR code. Just to be clear, registering for this does not give you access to the collaborative thing. In OHDSI, this is for us to know how many people are there so we can adequately plan the session so you get the maximum benefit out of it. This QR code should, send you to our website with a little sign up form, and then that's about it. So the last thing that I also want to highlight again, and next slide, please. Last thing that I want to highlight again is that the platform that has been shown, everything that has been shown is open source. So it's pretty much under the most permissive license we could find, the Apache license. So download it, install it. If you run into any trouble, which you will not, but just in case you do, in the edge case of that you do run into trouble, talk to us. We are very helpful. We are very happy to talk to people. We will help you through anything you want to do, including installation, setup, data ingestion, user onboarding, user role setting, whatever you have. And if you have some features that you're super interested in, go to the GitHub repo. Also, we take actively any ideas that the crowd, the users can provide, right? So Yeah, I think that is pretty much the last of my slide. I think I would be left with one more, which will be the thank you for your time, and thank you for listening. Thank you for not dozing off. There's the three of the presenters that we had. Please reach out to us. We are very happy to talk to any of you. And now I will stop talking and let the questions flow in so we can answer some things.
Thanks so much, Karthik. And think really wonderful. I think it's amazing to see how data for life evidence is evolving from the last time I saw that platform. And I think there's so much potential, right? What you just said about doing a community-based network study using data for life as a platform. There's so much we can do with this platform now. Just starting off with a question around FAIR. I know you didn't go so much into data for life FAIR. Understands more on the metadata. Have you got examples of a OMOP database actually applied on FAIR to discover OMOP database? Yeah.
Interesting. Okay, you know what? Let me bring in somebody else also from Data for Life.
Maybe another
Tim,
section,
I see
right?
you're in the call. I know you are a lot more actively involved with FAIR and datasets. There he is. Datasets. Could you talk a little bit more about whether we have done any OMOP datasets on it?
Yeah. Hi, great to meet all of you. I'm Tim. I'm the newest addition to the Data for Life team here in Singapore. I've joined as Chief of Staff here, and I am with Data for Life already since, I think, 6 years roughly. Started back in Germany and couldn't get enough of Singaporean food, so that's why I'm now here. Yes, regarding OMOP and FAIR, I think that's definitely something which is quite new to us. So we have not yet integrated these two solutions. However, I think there's like also in Europe some tendencies towards defining standard sets of metadata that can be used to really describe such data meaningfully. I think just the other day we also talked about ARIS, so ARIS, basically the OHDSI package, which can be potentially used to explore the different data sets. And our platform already offers the opportunity to provide custom metadata per data set. I think something for sure where we would need to dig deeper. And I think if there is the community also available to really define which of these metadata are meaningfully for the community, so we can pre-populate them in the platform. So whenever you basically create such a new data set, the platform will directly ask you for this information, and we can then kind of make them filterable. So the dataset overview that has been presented today by Karthik, and I think Amit also has briefly shown it, allows for some advanced filtering. It's disabled in the demo instance, but here I think we are super open and also super curious to learn based on the actual experiences from the community. So I guess the more OMOP data sets we ultimately will have in our platform, the more interesting it will become to make them credible.
Thanks, Tim. I think there's a lot of use cases we can build. Like if you look at the OHDSI evidence network, in fact, I think now we are at the juncture of trying to make them discoverable in a way that's not so revealing, but at the same time, you get to know what metadata is out there to start some of the community studies.
I mean, it's basically as if you would have said in one of the talks Karthik, Peter, and I had earlier this week, where we also said, okay, how can we kind of grow our platform to support those type of use cases? It's
talk to us, Mukesh. Talk to us. We are happy to do more stuff. Talk to us. So again, the platform is quite agnostic. Most of the solutions we try to build are quite agnostic. So if we can think of a problem, we can potentially think of a solution.
Okay. Thanks. Okay, more questions. I'm sure there are more questions from the audience today. Yeah. Lynette, I think I saw a hand raised earlier.
No, sorry, that was excellent. But thanks for the presentation.
Yeah, thanks. Okay.
Karthik, I have a question. The Atlas updates and the D2E platform are independent, right? You're not considering merging D2E into Atlas, right? They're different discussions, or are they the same? Nobody answering?
No. I'm thinking of Sorry, Peter, you wanted to say something. Go ahead. I was just
So basically, I think already now we have basically in data to evidence support for basically multiple code definition formats. So basically one is our own and one is the Atlas format. And so basically as well as a new version of Atlas will be basically integrated in our platform. But yeah, basically our platform will have Atlas, but it will basically, I mean, it's still an independent solution.
Okay, that makes sense.
And Song, just to add to that, what we will also try to do is to have sort of like a unified interface, because currently we have two different ways of building cohorts. Like one is, you know, how we build it, and then the other one is how Atlas builds it. We hopefully will try to unify that as best as we can. We will still, I mean, we're not sunsetting anything, but we will try to unify it so, you know, the experience is quite, for the lack of using a better word, uniform after unification across the use cases. Yeah.
If I remember correctly, I think last time there was a one-way compatibility with a D2E to Atlas, right? You could import into Atlas, but some of the settings might need to be manually checked because it's not 100% compatible. So that I understand the compatibility between the two tools, but just because you brought up the conversations you're having with the Atlas working group at the end of your presentation, I sort of got the impression, are you guys thinking of integrating both of them into one tool and also, you know, as part of the OHDSI's standard softwares? Or would this continue on to be two independent softwares? Maybe it's too soon to talk about this at this moment, but it seems from the Atlas perspective, the Data for Life team here is helping with the working group on coming up with a better user experience in terms of the UI currently to eliminate some of the learning curves that we're currently facing. But from a you know, work perspective, right, you guys are doing some sort of, I would say, duplicate efforts in both your tool, D2E tool, as well as the Atlas working group contributions, right? So I was thinking, could they be merged? What is Data for Life's thoughts around this? But yeah, I think I get your initial response. Maybe in 1 or 2 more years, we will end up seeing something in one very soon. But yeah, I'll stop blabbering and open up the floor to Nicole.
Let's talk more at the global. Let's talk more at the global symposium. I'm sure. Hopefully you're coming there. Damn you! 9. No. So no. I mean, look. Just to close this off, and I'll do a quick note of it. So data to evidence is not just what Atlas does, right? I mean, it's not just a cohort builder. It has other functionalities that we have spoken about and stuff. So we do continue developing those other functionalities, but we are trying to unify. I would not say replace, but rather unify the interface that we have inside our system with the Atlas system. So when Atlas, let's say we redesign it, it becomes super user friendly, and we say, okay, you know what, as you said, there is no need to duplicate an effort of building different things. Then yeah, sure, why not? I mean, we don't really, again, no team wants to do double the work and maintain 2 different things. And you know, Peter would have already has told me that he will only support these many versions, and so we are well aware of the restrictions that have been placed on us. But yeah, I think Peter will add a little bit more on this before I think Nicole has a question.
Yeah, I just want to say, so I mean, it is correct. So basically Atlas effort is I think to a certain extent independent, but so Atlas will be one component of data to evidence. We still have basically our own data exploration code building tool. I think there are some specific use cases which cannot be covered by Atlas. And like Kartik mentioned, basically the goal is I mean, so we will integrate Atlas, and so therefore it will become part of our platform. But probably right now there's no basically complete unification of these 2 tools planned.
Makes sense. Nicole, sorry about that.
Oh, that's okay.
Yeah.
My question is pretty much in the same vein, but really just asking about the analytics side of things and the you know, the functionality between and the updates to the packages, the analytic packages. So the treatment pathways, for example, has been recently updated, the package. So I guess what's the strategy for making sure that the packages are most up to date? And then I guess what, you know, how do we do version control in this kind of a platform? Because if you've written code in sort of old packages, do they become obsolete? And so just sort of thinking through some of the updating on the analytics side.
Yeah, so I mean, this is obviously the case that if you have it integrated in one platform, I mean, in basically one Docker image, so to a certain extent, you rely on us as well to update certain packages. But I think they are basically as well, I mean, so, I mean, I think at the end, they are basically as well these, I mean, you can as well provide basically these log files for the study. And then I think you could, I mean, you can basically as well, run basically, I mean, install dependencies on demand, but I think that's basically functionality we are still currently looking into. But yeah, I think that's basically one of the big problems as well with network studies, that I think each site has a different set of dependent, I mean, of versions, and to manage that. But I think basically the idea for us is as well that we more or less integrate it in the execution flow, that we then can basically update it. But I think that has its limits.
I think a question related to this is, so in your Jupyter interface that you demoed just now, you're only calling the libraries, right? So I'm assuming the libraries have already been installed in the back end and you're calling it, right? So I think what Nicole was asking is, say a version of the package is updated right now. If I understood what you explained correctly, Peter, is the platform itself doesn't have a functionality to get install packages, right? It calls existing packages in the backend in which you guys currently control. Is that correct?
Yes, I mean, so that's how it's basically currently run. But I think we have the functionality actually to install it based on the log file.
Okay.
Just, I mean, so that's basically some next step. And then there's, I think, a slight difference between the design time and the runtime for us. But I think we are getting into details there.
Yeah.
So I think I mean, we are aware of that challenge, and I think we basically have some solutions for that in mind.
Yeah.
And with basically that, with the execution, basically a certain set of packages is installed. I mean, I think the idea behind Strategos, and I think, yes, I mean, we as well basically in the context there with a team which is developing that. I mean, I think the idea is to have the JSON file and you have an log file. And I think they're as well thinking about whether they integrate it into one file at the end. But our idea is as well that our flow will respect that if it's provided.
Makes
and
sense.
that's basically by that automatically installs the dependencies which are required for that particular study.
Thank you.
Okay. Any other questions? We're right at time, 12 p.m. All good? Yeah. Okay. All right then. So yes, thanks again to Cynthia as well as Data for Life team for bringing us through. And I'm sure there'll be a lot more collaborations coming from here once we go forward. Okay then. We'll sync up in 2 weeks' time for the community call. Yeah. Thanks everyone.
Bye all.
Thank you, everyone.
Thanks. Bye.
Have a good
Thank
lunch.
you.
Bye-bye.
Bye-bye.